climate change has always been a focus in the recent years, but as we see these new catastrophes come in, especially in the United States as well, where we're based, you have these wildfires earlier this year, and you have Hurricane Helene and Milton, right? And oftentimes, we see these disasters play out, but now we're seeing real consequences. I have been spending a lot of time looking at the intersection of machine learning and weather, where previously I was hoping to build AI weather forecasts, where previously running partial differential equations, right? Building these weather forecasts cost about $2 billion per year in supercompute, and a majority of supercomputers are spent on some form of numerical weather prediction. But when you see machine learning being applied in San Francisco and in AI, but when you can think about it in real world applications in the physical world, right? Especially in weather forecasts where many different countries cannot afford high fidelity weather forecasts. And as a result, with machine learning, you can compute partial differential equations faster, allowing you to cut costs by 99% and increase resolution by 100 times. When you start to see that kind of revolution and being able to understand not only just weather better, but as how Earth evolves over time, we can start to think about what is the application layer, right? And this is where we're focused in, where how can we think about increasing intelligence for our understanding of Earth to do something about it. Our company is called Aeolus. We start to think about this, because the intelligence part has gone much better. But when you think about, okay, what has been happening in the last few decades, and then what is going to happen going forward, right? You look at like 2005 Hurricane Katrina, for example, over $200 billion of damages were incurred, and a lot of insurance companies went insolvent, unfortunately. And you look at, okay, fast forward last year, right? Like you had Hurricane Helene and Milton, where, frankly, they weren't even, blazing category 5s, but because insurance premiums have doubled every single year for the last couple of years in many coastal places, not many homes were insured, and people cannot afford, hurricane focused insurance, and people are not willing to pay for this. And when you start thinking about, okay, what is going to really happen in the next decade or 2 decades? It simply just doesn't work. The economics is very, very difficult to sustain, and we cannot insure out of climate change. And so what we focus on is like, how can we prevent these catastrophes from happening in the first place? So in literal terms, on what we do is we fly planes around hurricanes and disperse salt, super small salt, which just redistributes the energy from the center to the periphery of a hurricane, allowing you to reduce max wind speeds quite significantly. And by doing so, we talk about, okay, how can we build resilient cities going forward, right? And I think really, if you stretch this out 2 decades, 3 decades, even 10 decades, out to a century, right? You have to start, proactively intervening and not just having reactionary measures, right? Where I'm from, in Japan, we've spent billions of dollars on disaster infrastructure, right? We've built, columns under Tokyo where water can flood in so that, technically, the Tokyo is more protected, right? But when you think about, okay, does this actually solve the problem? No, the problem itself is the intensification of these events due to climate change, which I think, unfortunately, we haven't, tried our best to address yet. But I think with the power of machine learning, with the power of new hardware and aviation, we're able to start looking into the intervention side. In many countries, forecasting has been, the number one solution / the way to reduce damages, right? So you look at, okay, Japan has been, spending a lot of money being able to forecast these systems. The UK obviously has spent a lot of effort into that as well. Going forward, we talk about, interventions being incredibly important, but to be able to intervene, you have to also be able to show that, you're doing it safely, right? That you're not, you're not having, unintended consequences that have to be properly measured. And so that also means your modeling has to keep getting better, specifically the predictability and the attribution aspect, right? And so for us, what we think about is, okay, how can we leverage new, high performance compute, like putting into GPUs where, a lot of the weather forecasts, a lot of the models have been ran on Fortran, right? It is ran on CPUs, which is incredibly expensive, right? Like if you were to do, a full physics simulation of a hurricane, it's about, $95,000 per run. And if you're doing initial condition perturbations, it's going to be in the millions, right? So you have to really think about, okay, how can you speed this up so that we can have higher fidelity forecasts? So one, we can, react, but also, be able to measure, unintended consequences when we start intervening. I'm really interested in understanding the public-private consortiums slash public-private partnerships going forward. I think, climate change not only impacts, governments for obvious reasons, but also has, huge financial burdens into enterprise, right? And I think it's most beneficial in many cases where, we're having proper partnerships where we can motivate each other, not just through, different countries partnering, but different governments and enterprise working together to push, resilience for humanity to keep, evolving and to be innovative and to be disruptive. We have to start thinking about, how can you, take the pre-existing structures, amend it to what we can, kind of use and rely on for centuries.